Assalamualaikum to Dr. Sushilawati. My name is Nur Aina Jiha binti Muhammad Rahimi. Nama matrik CF220135. I would like to presenting about introduction and objective. Introduction. The amalgamation of mechanical and electrical system, commonly denoted as M&E in the realm of construction, entails intricacies of considerable complexity. This system integral to the subject as habit variations shaped by societal living standard, climatic conditions, and the quality standard of specific structures. It is imperative to recognize that a visually appealing and structurally robust building relies heavily on the efficiency of a well-designed M&E system for optimal functionality. The mechanical system encompasses services delivered by machines, including but not limited to HVAC, heating, ventilation and air conditioning, site utilities, plumbing, and fire protection, all of which are prevalent in constructions across Malaysia. On the electrical front, its significance is underscored as a pivotal component in contemporary building infrastructure, particularly in the realm of electrical power consumption. Next, objective. The first one is facilitate an educational visit to a designated building for a comprehensive case study experience. Second, create detailed reports and schematic drawings to effectively illustrate, explain, and justify the M&E system within the selected building. Third, adhere to specific standards and requirements throughout the documentation process. And the last one, ensure clarity and coherence in presenting the intricacies of the M&E system through comprehensive reporting and schematic representation.
Okay, for background building, for this project, our group visited one of UTHM building which is located on Academic Building, Block E14. This academic building located at University Tun Hussein on Malaysia, Parit Raja, Batu Pahat Johor, which is about 20 km from Batu Pahat town. The purpose of this building is to serve as a venue where students can physically attend classes, engaging in face-to-face educational season to enhance their learning experience.
Assalamualaikum. My name is Muhammad Nur Akmal bin Mat Zairi, CF201362. For electrical power distribution system, uh, the E14 building at University Tun Hussein on Malaysia incorporated a solar power electricity, minimizing its environmental footprint. Sunlight is harnessed by solar panel to generate DC electricity, which is then transformed into AC through inverter. This innovative system seamlessly blends solar-generated power with conventional components, exemplifying a forward-thinking and eco-friendly approach. For the capacity and efficiency of the electrical distribution at E40 building is evaluated based on its capacity and efficiency. The capacity assessment consider the efficiency of the inverter, the capacity of the solar panel, and the energy storage capacity. Efficiency is determined by both conversion efficiency of the solar panel and the efficiency of the inverter. The overall system efficiency is influenced by load management plans, matching solar energy production to building the energy consumption, and performance tracking monitoring system. Sustainability is also a key consideration, with a focus on reducing carbon emission from solar energy production. Regular maintenance is crucial for the maintaining optimal efficiency. For suggestion for improvement in E40 building, we are propose the method of E40 and 50 building is combined to their electrical distribution system by incorporating modern energy storage technology, integrating smart grid advancement, upgrading inverter, and adding backup power option. This comprehensive energy management system aims to provide centralized management and a joint maintenance training program, ultimately improving resilient and efficient.
Okay, next for the lighting system. Fluorescent lighting is a highly versatile type of lighting that most likely encountered at the office, school, or grocery store. It is known for energy efficiency compared to incandescent and halogen light bulb and a lower price compared to LED. Okay, next we are focusing on linear fluorescent tube because E14 building use that type of lamp. Fluorescent tube are commonly used in overhead fixture like trough in all type of a commercial building. Okay, next is fixture and control mechanism. Many fluorescent fixtures have more than one tube in order to provide more light. This lamp must have individual starter and ballast for each tube. The fixture may appear to have two tubes working off one ballast, but actually there are two ballasts built into one case. Fixture with four tubes similarly have four starter and four ballasts. In some kind of fixture, the starter are built in and cannot be individually replaced. Since there are only three primary parts in a fluorescent lamp, we can usually take care of any repair ourselves. All fluorescent lamps grow dimmer with age and they may even begin to flicker or flash on and off. Okay, for the principle of operation, a fluorescent lamp generates light from collision in a hot gas plasma of free accelerated electron with atom, typically mercury, in which electrons are bumped up to higher energy level and then fall back while emitting at two UV emission lines, 254 nm and 185 nm. The thus created UV radiation is then converted into visible light by UV excitation of fluorescent coating on the glass envelope of the lamp. The chemical composition of this coating is selected to emit in a desired spectrum. Okay, next for the construction. The gas inside a fluorescent lamp tube is composed of noble gases and low-pressure mercury vapor, with a total pressure of roughly 0.3% at atmosphere pressure. The most popular design used two filament emitters, one at each end of the tube. They are heated by a current to release electrons that, through impact ionization, exceed the mercury gas and noble gases. Only whole light bulbs are capable of experiencing this ionization. Okay, for increased lighting efficiency with LED driver and fluorescent ballast. LED and fluorescent light cannot be powered by the electrical current from a conventional outlet, in contrast to incandescent bulb, whereas fluorescent light requires to a high voltage impulse to ignite before switching to a low voltage, high frequency alternating current. LED just require low voltage direct current. We will need an electronic ballast or driver to change the electrical current coming from the outlet into a format that your light can use.
Assalamualaikum and hi. My name is Noshafika Azri binti Muhammad Amin. My number matric is CF220190. Today I would like to talk about LED drivers and fluorescence balance. How to increase lighting efficiency with LED drivers and fluorescence balance. Upgrading ballast and drivers can improve your lighting performance and efficiency. Some common reasons to replace ballast and drivers include: first, light quality. All fluorescence ballasts can flicker and harm. New electronic ballasts are quicker and create constant illumination. Dimmability. The ability to dim the lights when full brightness is not needed can cut your energy usage and create a more welcoming atmosphere. And the last one is controllability. Drivers and ballasts that are compatible with building automation system occupancy sensors can reduce energy costs and allow easier control over a room's appearance. LED driver basics. An LED driver transforms the high voltage alternating current in your building's power supply into a low voltage direct current. Some drivers simply supply a fixed output, while others are dimmable and can interface with occupancy sensors and building automation software. When choosing a driver, consider the following features: input and output current. First, be sure the driver will be able to connect to your building's power supply and generate the current needed by your lighting. A driver's output can vary in voltage, amperes, and watts depending on the type of LEDs they are designed to power. Many drivers have programmable output levels, allowing them to work with a range of features. Harmonic distortion. Like fluorescence balance, LED drivers are electronic devices that draw irregularly from your building's power supply, which can disturb the frequency of your alternating current. Drivers are rated by total harmonic distortion, with higher ratings creating more distortion. Insulation level. Some high-power LED drivers are Class 1 electrical devices, carrying fire and electrocution risks. They must be well insulated and handled with care. Class 2 drivers emit a low voltage output which carry less risk and require minimal insulation. Dimming method and type. Not all drivers are dimmable, and not all dimmable drivers use the same input. For example, a 0 to 10 volt dimming method relies on a low voltage signal that comes to the driver via a dedicated circuit. Drivers also vary in their dimming range. Some drivers can be set anywhere from 100% to 100% of full brightness, while others cannot go below a 20% threshold. Safe and security. Building security is the protection of property, assets, and occupants from intruders, perpetrators of violence, and unsafe or hazardous situations that can cause them harm or damage. Its goal is to deter, prevent, detect, and respond to physical security violations effectively. In E14 building, we noticed in that building did not install CCTV. CCTV is vital in determining any inconsistency or illegal activity that may happen on site. With access to recorded footage, a reliable perspective can be used to settle security complications in criminal cases. This is why well-placed CCTV surveillance cameras help deter crime. Safe and security. So, the suitable safety and security system to install at E14 building is CCTV. CCTV or closed-circuit television camera use advanced technology and recording processes in order to allow business to lower their costs while protecting their asset. There are a variety of benefits business can avail by installing a video surveillance system, including prevent and reduce chances of theft, real-time video surveillance, useful criminal evidence.
Okay, this is a layout for drawing A14. This is before we recommend the lighting and the power distribution and plus the CCTV. Okay, this is a drawing for A14. After we we recommend the power distribution, we add the one building to conduct all the system for the lighting and the CCTV at the A14. Then we plus the three lighting and we plus 4 CCTV to see the area E40. In the conclusion, the E14 building at the University 2021 have implemented a solar power electrical distribution system with a high efficiency fluorescent light lighting feature. The solar panel use mercury vapor fluorescence to produce visible light in order to guarantee resilience, efficiency, and capacity. The video also includes a smart grid technology, backup power option, and contemporary energy storage technology. Modern technology like upgrade the investor technology and larger solar panel capacity suggest as way to the further enhance the electrical distribution system. For continuous cost-saving maintenance, workers should participate in frequent training programs. The conversion of electrical current into a format the high-efficiency lighting feature can require LED driver and fluorescent bullet uh, fluorescent ballasts. This improve lighting performance and efficiency by addressing issues with light quality, dimmability, controllability, input and output current, harmony, dissolution, and resolution level. The building security measure could be improved by installing CCTV, surveillance camera, and strategic location through the operation area to prevent the crime and provide the real-time footage that can be easily viewed from remote device.